Hello, I'm Professor Rad, and today we're going to talk about discrete probability distributions. So in this video, we're going to start out with a few definitions, and then we'll work through several examples of applying some of these definitions. So the first two definitions are actually a callback to when we were organizing our quantitative and qualitative data. So remember that quantitative data could be one of two things. It could be discrete or it could be continuous. So the same thing's going to be true when we're looking at our random variables, which are basically like our events that we're interested in when we're talking probability. So a random variable is going to be discrete if its possible values can be listed out, just like with a discrete, variable. And a random variable is continuous if it can be any value on an interval. So some discrete variables include things like numbers that you roll on a die, or if I pick a whole number at random. For continuous variables, this could be time or height. So what's the probability that somebody's going to be taller than 6 feet? Or what's the probability that I get to work between 5 and 10 minutes? Okay. So we will be talking about both of these types of probabilities, but we're going to hold off on continuous probabilities for a little while because they're a little bit more complicated, let's say. So we're going to hone in and focus on discrete probabilities for this unit. And then let's define a discrete probability distribution. So a discrete probability distribution for a discrete random variable specifies the probability for each possible value of the random variable. Well, that's really vocabulary heavy, isn't it? Basically, it's going to be a table that lists out all the possible outcomes and the probability of each of those outcomes happening. So let's go ahead and look at an example of creating a discrete probability distribution. So in this example, it says that M&Ms are mixed so that 13% are brown. Oops. So let's go ahead. Okay, that's kind of brown. 13% are brown, 13% are red, 20% are orange. A real good orange here. Let's do gray, I guess. 14% are yellow. 16% are green, and the rest are blue. And then let's state the probability distribution. So for our probability distribution, we have a column called X. X is the event that's happening. So in this case, the event that's happening is the color of the M&Ms. So we're going to list all of the different colors of the M&Ms here in this first column. And then P of X is going to be the probability of those colors. So we'll list the probability of each color here. So let's just list out the colors in the order they're given to us. So they told us brown, red, orange, yellow, green, and blue. And then we'd like to find the probabilities. So previously, there were a couple of different ways that we could find probabilities. One way was taking the total number of events, like the total number of each color that happened, and dividing by the total number of events. But we don't know that here. We don't know how many M&Ms are being mixed together. We do, however, know the percentages of those M&Ms that are being mixed. And remember that you can turn a percentage into a probability by dividing by 100 or moving the decimal point. So for instance, this 13% that's brown, I can move the decimal point to the left 2 places to get 0.13. Same thing is true for red. Since we have 13%, that's going to be 0.13. 20% are orange, so that's 0.20. 14% are yellow, so that's 14. 16% are green, cool, 0.16. And the rest are blue. So I don't know how many is the rest, but I do know that since these are all the possible colors of M&Ms, they do have to add up to be 100%. So let me, oh gosh, let me grab a box from somewhere. Yeah. And let's throw some work into this box here. So let's start out by adding together all of the percentages that were given to us. So we're going to add 13 and 13 and 20 and 14 and 16. So those are the probabilities we've been given. So we end up with 76. That sounds right. So these percentages all add up to 76%. So since the rest are blue, we can subtract that from 100. That will give us 24% of the M&Ms are blue. So 24% is going to be 0.24. And there you go. That's how we can fill in our probability distribution. Okay, let's do another example. Now, if you're following along in the guided notes for our class, I did not put this example in. I decided to add this in later after I made the photocopies of those guided notes in fall of 2022. So you probably don't have this in your guided notes. So you can do this one like on an extra sheet of paper in a notebook, or kind of squeeze it in underneath the last example, something like that. And I wanted to add this one because this is a frequently missed question on a test. So star this, make sure you have an example like this one. So this example is very similar to the last one. So here we have a bag of 50 Skittles, and we're told that 8 of them are purple, 12 are red, 6 are yellow, 13 are orange, and the rest are green. So this one is really, really similar to the last example. We have some candies, and they're coming in a bunch of different colors. So let's go ahead and write their colors. We've got purple, red, yellow, orange, and green. But this one is different from the last example in a really important way. So I'm going to go back to the last example, and we had 13% were brown, and we were able to just move a decimal point and get 0.13 because we weren't told the number of brown M&Ms, we were told the percentage of brown M&Ms. On this new example we're going to work through, we're told 8 Skittles are purple. We're not told the percentage of Skittles that are purple. Oh, that's terrible. So I'm not going to do that. I'm just going to underline it as I talk about it. So we're given a number of Skittles, not a percentage of Skittles. So we can't just move the decimal point. Instead, we're going to have to take the number of purple Skittles out of the total number of Skittles. So over here on the side, I'm going to do 8, and I'm going to divide that by 50. And that gives me 8 over 50 is going to be 0.16. Oops. So I'm going to put 0.16 over here. Now, in this case, my calculator's default is to give me decimals, so that's what I'm going to put my answers as. But if you wanted to, you could also write this in fraction format. So let's see, that would be 4 out of 25. So you could put 4 out of 25 for the probability here as well. But I'm just going to stick to decimals because that's what my calculator is going to give me. And as long as they're nice decimals, why not? All right, next we have red M&Ms, or Skittles, I'm sorry. We have 12 red. So I'm going to do 12 divided by 50. And that's going to give me 0.24. And we can fill in the rest of this table following that technique. So for yellow, we have 6. So if I do 6 divided by 50, that's going to be 0.12. We have 13 that are orange, and if I do 13 divided by 50, that gives me 0.26. Now for green, we have the same situation that we had with the blue M&Ms. So we're just told that the rest of the Skittles are green. So 2 different ways you could think about this one. You could add these up, and think of them as percentages, right? So 16%, 24%, and so on, and subtract from 100%. Or I'm going to do this one a little bit different just so we can see a different way. I'm going to add up the total number of the Skittles that we know. So 8 and 12 and 6 and 13 is giving me 39. And since we know there are 50 Skittles total, we can do 50 minus 39. And that will give us 11. So I know that there are 11 green Skittles. So to find the probability of finding a green Skittle, I'm going to do 11 divided by 50, and that should give me 0.22. Now, if I look at my work later, I might be kind of confused by some of my work. So it's important when you're writing notes or when you're doing your work on an assignment that you keep your work organized and labeled so that when you look at it later to study from, it makes sense. So here are some ways that I could rewrite my work a little bit better so that it makes more sense when I go to study from it. So for example, one way would be to list out the work right next to the table where I needed to have it done. So for instance, here where I found the purple and I did 8 out of 50, I could write that there. And then for the red, I would do my 12 out of 50, which is 24 or 0.24. And so on. So this is kind of giving myself a little guide here so that in the future, I know how to use this example to help me to solve other problems. We have 13 out of 50, 26. Now for green, there isn't much space here, so I probably would do my work for green over on the side. And all of this work would now be labeled for green, so I would know my steps in that process. I added up the different colors, got 39, and then I subtracted that from the total to get my 11 green Skittles, and then divide that by 50 to get my answer. So organizing your work in this way really does help you. It helps you if, for example, you can have a formula card for a test. It helps you to write a good example to help you when you're taking that test. It also helps you to know how to work through your homework and how to study better. And you're more likely to get some more partial credit because it helps your teacher follow along with your process as well. Now, before we leave this new example, I also wanted to point out if you wanted to check, remember that if we're thinking in terms of percentages, these all need to add up to be 100%. So if we wanted to use this to check, all of these probabilities are going to have to add up to be 1. So let's do 0.16 plus 0.24 plus 0.12 plus 0.26 plus 0.22. Awesome. We end up getting 1 in the end. So when you have a probability distribution, the total of the probabilities should be 1. And that's where we're going to pick back up in our notes. So in a probability distribution, all the probabilities must add up to be 1. So let's take a look at these two examples here of using that kind of as a check. So for part A, it says determine whether the table below represents a discrete probability distribution. Now there are a couple of things here that are telling me this is not a discrete probability distribution. So take a moment and look at it and see if you can figure out what those things are. So one thing that stands out to me is this negative 0.3. Remember that a probability, when we looked at those properties of probabilities or the characteristics of probabilities, probabilities always have to be in between 0 and 1. So if you get a negative number for probability, that doesn't make sense. There's no way that can happen. Another thing that I'm noticing is that if I were to add all of these up, I'm going to end up getting, I think in this case, 0.9. but let me double check that. Yeah, so I end up getting 0.9, which is not 1. So the probabilities should be adding up to 1. Now, I am going to amend that a little bit because when we use the empirical rule and we're using proportions to approximate probabilities, or if we are finding probabilities but we're rounding our answers, then you might end up getting something like 1.001 as a total, or you might get 0.999 as a total. So that happens if you're in a situation where you've been doing some rounding. In this case, 0.9 is pretty far from 1, and this negative number is really fishy. All right, let's take a look at example B. It says complete the probability distribution below. So to complete this probability distribution, we're going to do what we did in this new example to figure out green. So to figure out green, we added up all of the Skittles that we knew, all the colors that we knew, and then we subtracted from the total. So in this case, we're going to add up the probabilities that we know. So 1/2 is the same as 0.50. So I'm going to do 0.50 plus 0.10 plus 0.25, and that gives me 0.85. So let's see if I can add this here. 0.10 plus 0.50, 0.25 is 0.85. And then I can subtract that from 1. So 1 minus 0.85 is going to give us 0.15. So the probability here of 1 is 0.15. Now, I do want to point out, notice that the values for x, they can be anything. They can be colors, they can be numbers, they can be, words, anything that we're dealing with. So the fact that the x value is negative is not a problem. What would be a problem is if the probability value was negative. So that's where we're going to wrap up this video. In the next video, we're going to start doing some things with probabilities. So we're going to start, combining probabilities or looking at like opposites of things that are happening. So looking forward to seeing you then. In the meantime, I hope you found this video to be helpful, and I hope you have a fantastic day. Bye for now, everybody.